I'm sorry, but I find this original symbolic dynamics too tedious. So I will use the symmetry-reduced symbolic dynamics that we already know how to use. So let me just remind you what it is. So when I have 3 disks, the important thing is that when I bounce, so if I come from here, there are qualitatively 2 different ways of bouncing. So if I come from the disk, I return to it, or if I come from disk, I go to the next one. So if I, instead of labeling the disks, which don't have any meaning because they're all the same up to the symmetry, if I, instead of labeling the disk, I use the dynamics as a label, then I can give every bounce which says return where it came from, I'll call it 0. And every bounce that says go on to the next disk, I'll call it 1. Then symbolic dynamics is 0, 1, and it's total freedom. There is no grammar. So what we do by using symmetry reduction on this problem is we replace it by topologically different labels, and we get rid of the original labels which were good up to permutation. But this is topologically distinct motions. So either I go back or go forth. If I use these labels, this might be the strip 0, this might be the strip 1 in the future. This might be this in the past that I came from bouncing back, and this one I came from going to a different disk. And then every one of these regions, you can get a unique symbolic dynamics label which encompasses both the past and the future. So for example, this is something in the future will go to 1, and it came from 1, meaning came from bouncing from a different disk. And this region here will be 0. This region here will be 0, 0. And this is flip over. So this will be 0 in future, 1 in the past, and this will be 1 in the future, but I executed motion 0 in the past. So I can have a doubly infinite itinerary if I know the past and the future. These little regions will get smaller and smaller and they become points. So the thing that's confusing about here, that everybody on this line had the same future, that gets resolved by looking at its past. So it turns out that when you look at dynamics of a billiard like this, if you specify any infinite sequence in past and the future, there's only one solution in a state space that does it. There's only one trajectory, because these guys all shrink exponentially.